Hey everyone! Welcome to our video report on the critical path method, often shortened as CPM. Before we jump into the topic, let's introduce our team. I am Ariel Dave Rodrigo, the first presenter of the group, and I'm with Marivic Molina, Angeline Peñaranda, Christopher Cardoza, Catherine Paglinawan, Nico Villarosa, and Luella Yata for the presenters. For the flow and slide making, we have Shara Joyce Alvarez, Vanessa Desiderio, Mary France Faune, Christine Joy Logdat, and Darjeeling Pabustan. We also have Andre Cayetano for the video editing. By the end of our topic, we hope you learn how to identify the most critical activities, understand how delays can affect timelines, and manage resources more effectively. Each of us contributed to making this report informative and engaging, and we hope you find it helpful. Now, let's get started with the basics of the critical path method. So, to start the topic, what exactly is critical path method? CPM is a project management technique used to plan and schedule tasks in a project. Its main purpose is to identify the critical path, the longest sequence of dependent tasks that determines the shortest time to complete the project. If any task on this path is delayed, the whole project gets delayed too. This method helps project managers know which tasks are most important and time-sensitive. It also shows which tasks are non-critical, meaning they have some flexibility and can be delayed without affecting the final deadline. By using CPM, managers can better allocate resources, avoid bottlenecks, and make smarter decisions to keep the project on track. It is especially useful in industries like construction, IT, and event planning where timing and coordination are crucial. In short, CPM helps teams stay organized, meet deadlines, and manage their time more effectively.
So what the activities in critical path method? The individual work, component or task required completed the project. Second, deficiency. So what is deficiency? The logical relationship between tasks, which is tasks must be completed before others start. That's how important deficiency. For three, network diagram. A visual presentation of tasks and their deficiency showing the flow of the project, which is will tackle later of one of my classmates. For four, critical path method. The critical path method, the longest sequence of dependent tasks with zero slack. It determines the shortest time in which the project can be completed. For five, early start or ES and early finish or EF. The easiest time an activity can start and finish without delaying the project. For six, late start or LS or late finish for LF. The latest time an activity can start and finish without delaying the project. For seven, slack or float. The amount of time a task can be delayed without affecting the project end date. Tasks on the critical path have zero slack. So, for our next reporter, which is Angeline Peñaranda.
How to apply CPM. Let's walk through the step-by-step process of applying the critical path method or CPM. This is a project management technique used to plan and control complex projects by identifying the most important tasks that directly impact the project duration. Step 1. List all activities. First, we start by listing every task required to complete the project. These are usually broken down from a work breakdown structure. Step 2. Determine dependencies. Next, we look at how tasks are related, which tasks need to be completed before others can begin. These relationships are known as dependencies. Step 3. Create a network diagram. We then create a visual representation of the project using a network diagram. This shows the sequence of tasks and how they connect based on their dependencies. Step 4. Estimate duration. For each activity, we estimate how long it will take to complete. This gives us a timeline to work with. Step 5. Perform forward and backward pass. Now we calculate the earliest and latest start and finish time for each task using forward and backward passes. This helps identify any flexibility in the schedule. Step 6. Identify the critical path. Finally, we identify the critical path, the longest path through the network with no slack. These are the tasks that must be completed on time for the whole project to stay on schedule. By following this step, CPM helps project managers stay on top of deadlines and avoid delays. And now, we will going to demonstrate step by step on how to solve the network diagram problem or critical path. In this activity schedule, we will construct a project network, doing the forward and backward passes, determining the project completion time, calculating slack values, and lastly, we will state the critical path. We will be using this node convention here, which A stands for activity and T stands for time. ES is the earliest start where the activity can start, and EF is the earliest finish time. LS is the latest start time, and LF is the latest finish time. Now, let's contract the flow of the given activities. Since activity A has no predecessor, it will be our starting point of the flow. To start, activity B needs activity A. Activity C needs activity B, while activity D, E, and I requires activity C to be completed. Activity G depends on activity D, then activity F needs activity E. Activity H connected to activity E and G, while activity J need activity F and I. Next, activity K and L needs activity J to be completed. On the other side, activity M requires activity H, while the N needed activity K and L. And lastly, activity M and N has no successors. It will directly go into finish.
We will proceed to the actual project network, where we're going to apply the convention method. Let's start with the forward pass. Since activity A has no predecessor, the earliest time will be 0, so we can compute the earliest finish time using the formula. Earliest finish is equals to earliest start plus time. By applying the values from the given data, we will start to compute the forward pass. Since the estimated time for activity A is 3, it means 3 plus 0 is equals to 3, and we will just continue the process. Next is activity B that needs activity A to be completed before it can start. Since the earliest start for A is 3, then the earliest time for activity B is 3, so 3 plus 5 is 8. For activity C, 8 plus 11 is equals to 19. On the other hand, activities D, E, and I are connected to activity C, so their earliest start is 19. First is the activity D. 6 plus 19 is 25. For activity E, 5 plus 19 is equals to 24. While in activity I, 7 plus 19 is 26. To continue, activity F has 24. So 24 plus 6 is 30. Activity G requires activity D that has 25 as the earliest finish time. 25 plus 7 is 32. Activity H needs activity E and G. Since we're talking about forward pass, we will have the highest number, which is 32. The earliest start for activity H is 32, so 32 plus 9 is 41. For activity M, 41 plus 2 is 43. On the other side, The earliest time for activity J is 30, so 30 plus 9 is 39. Activity K and L needs activity J, so they'll have the same earliest start, which is 39. For activity K, 39 plus 4 is 43, while activity L, 39 plus 6 is equals to 45. Activity N needs activity K and L. Since 45 is the highest value, we will use this as the earliest start for activity N. So, 45 plus 7 is 52. The project's completion time is 52 days because the highest earliest finish time between activity M and N is 52. Now, after completing the forward pass and identifying the earliest finish time of the project, which is 52 days, we will proceed to backward pass. Since the project completion time is 52 days, the latest finish time for the activities or the finished activity M and N has to be 52. In order to identify this, we can use the formula for backward pass, which is latest start is equals to latest finish minus time. So the latest finish for activity N is 52. 52 minus 7 is 45. 45 is earliest finish time. For activity M, 52 minus 2 is 50. Meanwhile, activity K and L will get the latest start of activity N, which is 45, as their latest finish time. So for activity K, 45 minus 4 is 41, while 45 minus 6 is equals to 39 for activity L. Since activity J requires activity K and L, and we are talking about backward pass, we will have the lowest value, which is 39. For activity J, 39 minus 9 is 30. Activity F and I are connected to activity J, so they'll have the same latest finish time, which is 30. For activity F, 30 minus 6 is 24. And for activity I, 30 minus 7 is 23. On the upper side, the latest finish time for activity H is 50. 50 minus 9 is 41. For activity G, 41 minus 7 is 34. While activity D, 34 minus 6 is 28. Activity E requires both activity F and H, and the lowest value is 24. So for activity E, 24 minus 5 is 19. The lowest value between activity D, E, and I is 19. So this will be the latest finish for activity C. So 19 minus 11 is 8. For activity B, 8 minus 5 is 3. And lastly, the latest finish for activity A is 3. So 3 minus 3 is 0. The backward pass is completed. Now, the slack for an activity is defined as how long the activity can be delayed without extending and increasing the project's completion time. And it is calculated as slack is equals to latest start minus earliest start, or latest finish minus earliest finish. The slack for A would be 0 minus 0, or 3 minus 3, which will be 0. The slack for B and C will both be 0. For activity D will be 9. For E and F are also 0. The slack for G and H will be 9. And for activity I will be 4. For J will be 0, and for K will be 4. For activity L, still on 0, and for M will be 9. And lastly, activity N is 0, which means those activities with 0 slack cannot be delayed. The activities with 0 slack are called critical activities, while those activities that have above 0 value will have time to be delayed, but the project will still be completed within 52 days. So to sum it all up, our critical path are A, B, C, E, F, J, L, and N.
Inventory cost. Inventory costs include expenses related to ordering, storing, and potential losses from shortage or obsolete stock. Sakop nito lahat ng expenses na related sa storing, acquiring, and managing inventory. Nakapaloob din dito yung mga cost sa warehousing, shipping, insurance, and potential losses dahil sa obsolescence or shrinkage. Types of cost. There are 4 types of cost. The first one is ordering cost, expenses for procurement. It is a dependent and varies based on 2 factors. Yung 2 factors na yun is called cost of ordering excess and the cost of ordering too less. Yung dalawang factors na yun is they move opposite direction to each other. Yung ordering excess, nagre-result ito sa carrying cost of inventory. While yung ordering less naman is nagre-result naman ito sa pagtaas ng replenishment cost and ordering cost. Carrying cost, storage, insurance, and depreciation. Ito yung expenses na liable ang mga business for holding inventory stock. Yung cost na ito is napapalibutan siya ng maraming factors like storage, insurance, taxes, labor, utilities, and kahit opportunity cost. And lahat ng na-contribute sa overall expenses ng maintaining inventory. Shortage cost, lost sales, and back orders. Ito yung cost na dahil sa pagkakaroon ng shortage of stock, nagli-lead ito sa cancellation of orders and malaking kawalan nito sa sales dahil hindi mo na-meet yung standards or demand ng market. The last one is stock loss cost, theft, shrinkage, obsolescence. Ito yung pagliit ng company dahil sa hindi pag-evolve or pagsabay sa trend ng isang market and naglilid dito sa paghina ng company or worse is magsara yung company.